There is a massive stretch of the North Atlantic, roughly bounded by Florida, Bermuda, and Puerto Rico. It spans roughly 1 million square miles, yet it does not officially exist on any U.S. government map. Over the centuries, this unofficial zone has reportedly swallowed an estimated 20 planes, 50 ships, and hundreds of people without leaving a single trace. In March 1918, the USS Cyclops, a massive Navy cargo vessel carrying 10,000 tons of manganese ore and over 300 men, sailed into this region. It never sent a distress call, and no wreckage was ever recovered. It remains the largest non-combat loss of life in U.S. naval history. Then, in 1945, a squadron of 5 Navy bombers known as Flight 19 completely vanished during a routine training run. Even the 13-man rescue plane sent to look for them disappeared that very same day. By the 1960s and 70s, pulp magazines and authors began stitching these historical tragedies together. They gave the region a catchy name and sold millions of books proposing that extraterrestrial portals and the lost city of Atlantis were pulling these vessels into the murky depths. To understand what is actually destroying these vessels, we have to strip away the paperback mythology and look directly at the physical earth sciences of the North Atlantic. The first major scientific suspect is localized magnetic interference. Christopher Columbus noted bizarre compass readings here back in 1492, and the commander of Flight 19 radioed that his compass was malfunctioning right before he lost contact. Because geographic and magnetic north poles differ, compass needles pull from true north, a variance called magnetic declination. Along the agonic line, they perfectly align. Centuries ago, this crossed the triangle. Drifting westward 0.2 degrees a year, it now sits firmly in the Gulf of Mexico. In the case of Flight 19, radio transcripts show the lead pilot mistakenly believed he was over the Florida Keys, when he was actually hundreds of miles away in the Bahamas. He turned his squadron east, deeper into the open Atlantic, a tragic consequence of pilot disorientation, rather than magnetic interference. If magnetic fields aren't pulling these ships off course, the explanation for the missing wreckage must lie in the physical violence of the environment itself. The region's western edge is dominated by the Gulf Stream. It is extremely swift, turbulent, and travels up to 300 times faster than the Amazon River. This hyper-fast current acts like a massive oceanic conveyor belt, easily throwing inexperienced sailors hundreds of miles off course, and if a vessel does go down, the current rapidly erases the wreckage before search parties can even arrive. We also know this precise geographical area is one of the most heavily battered regions on Earth. The coastlines of Florida and Puerto Rico endure routine violent weather systems and are a magnet for hurricane activity. Recently, headlines have suggested that underwater craters releasing massive explosive bursts of methane gas might be sinking ships. But while researchers have found evidence of this off the coast of Norway, they highly doubt it is occurring in the North Atlantic. Violent storms and rapid ocean currents provide perfectly plausible ways for a ship to sink. But focusing purely on the ocean's hazards blinds us to a glaring error in the investigation itself. Instead of asking exactly how these ships sink, we need to ask a much simpler question. Do ships actually sink here more often than anywhere else? To find out, we have to ignore the paperbacks and look at global shipping casualty databases provided by institutions like Lloyd's of London. In 2021, 1.8% of global shipping traffic experienced a casualty or disappearance. But out of over 8,600 ships passing through the Bermuda Triangle, the casualty rate was a microscopic 0.02%. The danger here is 90 times lower than the global norm. The U.S. Coast Guard completely agrees with this assessment. Furthermore, aviation data from the NTSB confirms that almost all plane incidents in this area happen during standard runway takeoffs in the Bahamas, not mysteriously in midair. The math leaves no room for debate. There is nothing out of the ordinary happening here, and this patch of water does not even make the list of the top 10 most dangerous ocean regions on Earth. Human confirmation bias drives the persistence of the mystery, sustained by mid-century authors who discovered that a well-timed disappearance sold more books than a routine investigation. It is psychologically easier for us to imagine aliens and time portals than it is to accept the mundane, tragic realities of human error and bad weather. You are statistically safer traveling through this specific maritime route than you are navigating many other active waters across the globe. This region functions as a statistically normal segment of the North Atlantic. In the end, the data suggests that the lack of a mystery is the most significant finding of all.